Okay, so let's continue. Where's my pen? Oh, here it is. Okay, so thank you very much for coming to the webinar. My name is Achmad Mardiansyah, and then today we'll be talking about telecommunication evolution, started from very, very old. Perhaps you can see it. You still see it in some places, but most likely it's not. Yeah, so let's talk about that. So agenda. So in this webinar, we'll be talking about some topics here. Yeah, about introduction, about we do the review, just for refresh your memory about the telecommunication. Talk about topology, what kind of how the nodes are interconnected to each other, and then telco nodes, and then their functions, and then the evolutions to the latest generation. All right. So let's start. So for those who are new to MikroTik, I'm sorry, to GLC network, sorry. We are GLC, Garda Lintas Cakrawala. We are based in Bandung. We are doing training in IT consulting. We are partner for MikroTik, Ubiquity, Linux Foundation. We also have product for Radius Manager and then billing. And then we do regular events like we are doing today, which is the webinar. Oops. Yeah, my name is Achmad Mardiansyah. I'm also based in Bandung. I'm Linux user, MikroTik user, Cisco users. I'm programmer. I'm Python user. What else? PHP user, PostgreSQL user, MySQL user, and other users. I have a LinkedIn account here. So guys, if you are on LinkedIn, and then we can have a connection there. So it's good to have lots of friends. Past experience, 2021, we do network support. Previously, we do network automation, building wireless ISP, and still doing, most likely the projects are related to ISP. So we do like, yeah, network upgrade, network improvement. We upgrade from the bridge network, so flat network, to a more better networks like routed network. So we do IP planning and related to that. Okay, about the webinar itself, we started the webinar since 2010, so a long time ago. And then the topics are about networking, system administration, and programming. Okay, so if you don't mind, please introduce yourself. Okay. Yeah, just tell me where you're from, your background, so that we know where you are from. Usually there are people from Africa, Europe, and Asia coming to this webinar. Okay. Prerequisite, this topic is quite light, not too deep. So we assume you already know some informations like telecommunication in general, and then at least some little bit about signal. Okay, so talking about telecommunication, it's all started from things like this. Okay, thank you. We have a chat here from Rian. Okay, thank you, Rian. Thanks for informing yourself. Okay, any others? Yeah, welcome to DLC webinar. Yeah, so it's all started from these things. We know that with the microphone and then speaker, we can set up a communication. Okay, so we have a microphone here and then speaker over there, and then we can make a communication. So in order to make a communication, our device needs to be connected to each other. Okay, so and then it's end up to have a mesh connection like this. Okay, so and then this is very, very not good because it's literally wastes lots of cable. So we need to have a way to centralize those connection so that when we implement the telecommunications, it can achieve more efficient resource in this time. And this case is the money. Okay, so we need to have a hub for communication. Okay, so this is the hub. The hub is called central office. Okay, so or CO, and then this is how the central office looks like in very old time. It's done operated by a human. Okay, run by human operator. So that's why the telecommunication company now is still called operators. So because long time ago, no machines, it's all humans. So the humans, so this is you, okay? And then they connect the cable from your phone, from your house to the CO over here. Okay, so this is CO and then connect to that. And then every operators, they are handling a switchboard like this. So they connect your phone, your connection, your switch, and then to the other cables. And then this process is called switching. Okay. Here, also called PSTN, Public Switch Telephone Network. And then this CO function is to connect from one cable to the other cables, aka one customer, and then to the other customer. Okay. Others is they are doing a signaling, like an in-band signaling. So in-band signaling means the signaling is done in the same line, same physical lines with the data communication, with the data. Okay, so some example for signaling are for ringing and then routing from source to destination. So here everything is done by manual. So you have a route. So you have a customer that wants to call the number, and then you have an operator that okay, I want to connect you with this end. So here you need to know that in the early days of telecommunication, there is no dial pad. Okay, so as you can see here, no dial pad, no numbers. Okay, can you imagine how can you call without numbers on your pad? So that one is you have to do you have to turn a wheel there very quick, and then the customer the operator at the center office will pick up your call, and then you have to tell them that you want to call this number. So yeah, at that time the operator is doing switching function, routing function, and then call center function. So lots of them. Okay, so that happens in 90 in the after the Second World War. Still doing like this. Okay, there are lots of oops. There are lots of people working as an operator for telecommunication. And then the CO is improved, is more modern. We are doing mechanical switch, so there is no human operator anymore. So that function is replaced by mechanical switch. So it's very, very noisy. Okay, so it's good, no human operators. The phone now has a dial pad, so this one, so you can just dial the number that you want to call, right? So which is very good compared to the previous one. So switching is done automatically, so, but in mechanical, and then signaling is also done automatically, but in using in-band signaling. When we talk about data in telecommunication, data means voice. Okay, so if I'm talking about the telecommunication data in the early telecommunication, it means the voice. Okay, because that's the only service that they can provide, right? In 1940s, in 1950s, 60s, 70s, perhaps, yeah. yeah, main service for telecommunication is just call. Yeah, people want to make call. At that time, it was very wow. At that time, very aha moment. Very wow. Now, oh, you want to make call? You can make a call as long as you like. There are lots of options with that. You can do a call with WhatsApp and then Skype and then others, many things. Okay, so here CO has a function. So they are doing switching and then signaling. Okay, so this is improved, so which is good. So we are not finished up to that. So we keep improving. And then we invent the digital switching. Okay, so at this moment, there is no mechanical switch anymore. So it's not no noisy sound at the central office. Now everything is done by electrical, okay, electrical circuits. And then if you have been into a central office previously, most likely you will be feeling cold because inside it's air conditioned. Okay, it was very cold at the time. So I was working in my internship in a telecommunication company. I was doing some tasks in telecommunication room, and then it's very cold. And after that, few days after that, I got cold. I catch a cold. So yeah, yeah, it was an experience previously. So signaling is still doing in band, okay, and then all processing is using digital data. So we have there is a possibility that we are using ISDN here. So previously, the data from the customer, from the CP, we call it CPE here, to the central office is still analog, okay? It's just analog, so there is no 1 and 0. But now, with the digital switch, we can set up an ISDN client here, ISDN client here, and then when they connect to the central office, it's already 1 and 0s. Okay, so it's already digital, okay? And then the channel is still using associated signaling. CO function is still same. So the improvement here is the processing of switching and then the routing. Okay, so yeah, as I said, we are doing signaling. And then the signaling is CAS, okay? Channel associated signaling. So the signaling is done in the same cable with the data cable, so with the voice cable. So yeah, we cannot invent more services with that. So there is an improvement to split the network for data and then the signaling. Okay, so for example, this one. So from A to B, for example. So A will call to this central office 1, CO2, CO3. Okay, so from here, go to here, for example, and then go to there. Okay, so from A to B. Yeah, so so in this improvement, we are separating the voice call and then signaling. So this one is signaling, and then this one is voice. So they are using different cables. Okay, so what is the benefit of using common channel signaling? Or CCS, sometimes it's off-band signaling. Yeah, so they are using their own network for signaling. Sometimes it's called CCS, and then we are using version 7. Sometimes it's called CCS 7, and or sometimes people call it SS7, so signaling system number 7. So the benefit of using a split signaling network is we can utilize voice link. Yeah, so you can make more calls. Okay, and then it makes more money. And then we can create more services like hunting, SMS, toll-free, service number. So if we don't split the signaling, we cannot do things like 1-800, for example, 1-800 service, toll-free service, like if you have a fast food restaurant and then you want to want to order something. So usually they only provide a number which only consists of 6 digits. Okay, yeah, that one can be done with the common channel signaling. And then this is an example of SS7 architecture. Okay, so this is you, and this is your partner. You want to call them. Okay, the call, and then here's the link. Okay, so this is your central office, another central office, and then we are splitting the signaling channel and then voice channel. So we are not talking a lot about this SS7 because we have done the SS7 webinar previously. So yeah, for you, if you missed the webinar, just check our YouTube channel. All right, so yeah, so this is telecommunication topology. So if we talk about traditional telecommunication, so here they are. So they are using star topology. Okay, the central is a central office, and then all of them will connect to central office. Okay, and then the nodes will be the CPE. Here's the CPE, for example, and then here's the central office in the middle. And then if the network grows, and then the central office can connect to the central office. Okay. And then the connection, the cable, physical cable that connects between central office is called trunk. Okay, so that's why this is terminology that is used in the VLAN. Okay, and in the networking, yeah, VLAN trunk and then VLAN access. Okay, port access and then port trunk. So the same thing. So we can think as a central office like a switch. Okay, that is switching from this cable to this cable, yeah, from this customer to this customer. Okay, it's done by the central office. So that's why sometimes we call it exchange, sometimes we call it switching. Okay, so that's what they do. So we have a tandem switch that connects to other switch. Okay, and then if the network getting bigger and bigger, we have a regional central office here. We have a tall central office, another central office, and then here's the regional, like between countries, from my country to your countries, and so on and so forth. And in terms of services, same thing. Okay, in the telecommunications, in the fixed telephone, the services are voice. Okay, so people make a call. People wants to call from A to B. And then later on, they upgrade the equipment so that you can connect to the internet, which is packet switching, through their through the equipment in the center office. So we can say that in the beginning we are using modem. Okay, so V90 modem. Okay, so it's a long time ago. And then we have what is it? What is it? Telkom Speedy. What is it called? ADSL. Okay, ADSL. Okay, but now all operator or fixed phone operator is using a GPON technology. So this is the technology that is run on the local loop or subscriber line. Okay, so those are the story about the fixed network. So let's talk about the mobile communication. Okay, so previously the mobile station is not going anywhere, still in your house. So yeah, that's why it's called PSTN or POTS, plain old service, plain old telephone service. And then we talk about the mobile communication. So there is a requirement that people wants to move from one to other places, but they are still be able to make a communication. So that's why the end user is now can make a call while they are doing mobility. Okay, from A to B, they can make a call. So the first generation is done here. Okay, so in 1980s, So this is how it looks like. So we have a BTS based transceiver station. So it's called transceiver because it can do transmit and receive. Okay, transmitting and receiving. So we combine, becomes transceiver. And then we have central office here. So we can say this is like a CO, okay, central office. So the problem that the topology here is similar to the previous one. So only difference is here the access network. Previously, the access network is using wire, either it's fiber optic or copper wire. But now the access network is using air interface. Okay. So in order to have an air interface, we need to set up a tower here. The tower will do transmitting or receiving a signal, electromagnetic signal from the mobile station or mobile units. We call it. So the units, the nodes here are the BTS, okay, the MSC or mobile switching center or central office, yeah, or the mobile station. Okay, they're still using FDMA. So one customer is using one frequency. Yeah, and then the analog from the mobile station, from your phone, mobile phone, to the, so this is mobile phone. Yeah, mobile phone over here to connect to the tower is using analog signal. Okay, so that was it a long time ago. So after that there's an improvement in 2G. So here we have more complex in 1990s. So here we are using TDMA. So so even though if we have frequency F1, and then we will doing the time division multiple access TDMA for this frequency. So we have a time slot TS0, TS1, TS2, TS3. Okay, so that's the TDMA. So this concept is TDMA concept is also done by several network wireless vendors like MikroTik NV2 or Ubiquiti AirMax. So all of them, all those technology are using TDMA. Okay, but TDMA is done in telco. So yeah, that's the history. Okay, so here we are using, that's why it's called cellular. So one cell is using one frequency. This is F1, and this is frequency F2. Okay, and then all of them are connected through a mobile switching center. Okay, and then inside we have HLR and then VLR, home location register, and then visitor location register. So here we introduce the frequency reuse, and the good thing here is from your mobile station to the not MS, mobile station. MS is mobile station, and then MS is to connect to BTS. This one is already digital. Okay, and then there is also encryption for this one, and then here's the node. Okay, so again 2G is still focusing on voice. Okay, so we still improve ourselves, improve the technology. Okay, and then it becomes 2.5G. So it looks like this, 2.5G. So what's the difference is the air interface. So the difference is on this side. Okay, so no modulation here. Okay, so with the new modulation, we can deliver higher speed. Okay, and then for 2.5G, it has ability to connect to the data network. or packet switch, and then it's called GPRS. So here it is. Here's the new system. Here's the new node. Okay, a new equipment to be put on your operators. Okay, so we have GPRS network. So GPRS, General Packet Radio Service. There are two nodes here, SGSN and then GGSN. So actually this one is GGSN that is used as a gateway to connect the data network. So data network means internet. So it means that there is a router here. Yes. Are they doing NAT? That depends. So this is router. Okay. So here there is no router. So it's just normal, traditional telecommunication network. So this is the GSM node and interface. Okay, so if we put all nodes together, and then here's the architecture. Okay, so here this is the things that in your pocket. So you have a SIM card, and then you put SIM card inside the mobile station. Inside the ME. So ME is mobile equipment, and you have a SIM card, and then it becomes mobile station. Okay, so station that is mobile. And then you connect to the tower here. On the tower, there is an equipment called BTS. BTS over here. They are transmitting signal, electromagnetic signal to everywhere. Based on their coverage, and then several BTS, okay, is controlled by BSC, base station controller. Okay, and then from BSC, there is a MSC, mobile switching center over here. Okay. Yeah, so there is a mobile switching center over there, and then if they want to call PSTN, there is a gateway to go to PSTN. Okay, and then here is the equipment that supports the MSC. So we have a VLR here, we have HLR, and then we have authentication here. And then here we have EIR. EIR means equipment integrity, equipment. Forgot the I. R means register.
Identifier register.
Identifier register. Thank you, Jemy. So the purpose for EIR is to register your mobile ME. So ME will be registered in EIR. So every phone, you have email, right? EMEI, yeah. So all serial number of your phone will be registered here. So if somebody steal your mobile phone, and then you report to the operator, they will not be able to log into the network. Same thing if you buy phone from the black market, which is not registered here. So they cannot, even though if you put a normal SIM card, they cannot log into the network. So that's the purpose for EIR. Okay, so other node is GPRS node that connects to the internet over here. So this is packet network. And then GGSN and SGSNs, well, it contains a router. From which vendor? Well, that depends. Can be from Cisco, can be from not Juniper, Juniper, or Huawei, or any other vendors. Okay, so next we have a 3G. Well, improvement for 3G is their new modulation. So improvement on this area. Okay, and then it results in the higher speed. The BTS is called Node B, and then here we have a RAN, radio access network, and then connect to other nodes like previous. We have MGW, media gateway. yeah, for 3G. For the implementation, we can use UMTS or CDMA 2000. Okay, other, yes, as like a previous one, we have like a GPRS, and then this is for voice. Again, when we talk about telecommunication, the main things for telecommunication is voice. Okay, that's where they get the money from. Okay, next, I think it's your part, Jemy. So, guys, okay. I will hand it over to Jemy. Jemy is an engineer working in telecommunication. He is now living in Malaysia, in Kuala Lumpur, perhaps, yeah? Yes, Kuala Lumpur, right? Working in a telecommunication company there. And then today, he's sharing his information about telecommunication with us. Okay, Jemy, the platform is yours.
I no need to share my video, yeah, I think.
No. Yeah, well, it's up to you.
Okay. Okay, just prepare small thing. It's only add-ons from what you already share, Ahmad.
Okay.
Can see my
yes,
screen?
we can see.
Now?
Yeah.
Oh, sorry. Can see my screen?
Yes, I can see your screen. What about others? If you cannot see the screen, and then please say something in the group chat so that we can do something to help you. All right, Jemy, okay.
I just add on what Ahmad already explained is about the evolution of telephone network. Especially we talking about cellular network. Yeah. Okay. First, I need to introduce myself. I'm an engineer at Nokia, and this is more or less my experience so far. And this is my LinkedIn. If anyone want to connect, feel free to invite. Right now, I'm in Nokia, Malaysia, working as a senior engineer for subscriber data management. We can tell which part that we handle for the subscriber data management later.
Yeah. Sure.
Okay, first, I think Ahmad already explained about this 2G network.
Yeah.
More or less in the cellular, you have two big parts, the radio part and the core network part.
Okay.
Put the pointer. Okay. This is the radio access network, and this is the core part. In 2G, yeah, in 2G, you still have a BTS. This BTS, several BTS controlled by the BAC. Then several BAC will connect to the for the voice connection. They will connect to MSC, which is via also there's a PLR. Actually, nowadays they are combined node. Even nowadays we don't use 2G. Then they connect to HLR. This is where data subscriber located. So every subscriber data in the cellular operator will be located in the HLR. So all MSC need to connect to the HLR. The BAC also connect to the other part of the core network we call packet core, the GPRS network. Then the node called SGSN also connect to the HLR here. So if packet data, your connection will become from here to here for the user plane, not the control plane, yeah, user plane. But for voice, it will come from here to MSC, then to the voice network. Then it comes to 3G network after maybe around 1 decade. Actually, in the core network, not so many difference with the 2G. the difference in the 3G network only in this part of the radio. I think Ahmad already explained about there's a call node B, and this node base station will control by RNC. And the detail I think Ahmad already explained about the optimization on the radio side from 2G to 3G. In the core network, the one that feature introduced before in 2G, you have a feature voice, data, and also SMS. But in 3G, actually they introduced one feature called video call, mirror service, not only teleservice.
Oh, yeah.
So
Video
they
call.
also
I
mirror
remember that,
service.
yeah.
Yeah, video call. But unfortunately, this service is not so popular. Not so many operator can get money from this video call. People prefer not to use video call, and at that moment also there's OTT. We introduce the WhatsApp and all these things. So this is not very famous when 3G coming. After 3G, then they introduce what we call LTE, 4G LTE, and CS fallback. So what is the LTE? What's the difference with LTE and 4G? So LTE is actually a 4G, but it's not support the voice. It only support the data. So more or less, the network in the operator will be like this. So they will have a 3G network, the existing. Then they introduce LTE. So they need to add another box like this new MME.
Node.
Yeah, another node. Then this one, another node. This HSS is the preparation of replacement of the HLR in the 2G and 3G. So in the 4G, they will use HSS. What's the difference? Of course, about the protocol and all the efficiency, the optimization of the existing. So home subscription server, they introduce this. So when you go LTE, if your phone have LTE data, your user plan will come from your phone to the EU TRAN, then to this SGW, go to PW, then it's go to the ISP. Of course, this one has a faster bandwidth compared to the 3G. But at that moment, this one not support voice. So whenever you make a call, it will go to MSC. So when you request a call, it will call this SG interface paging that someone want to call. So you will make a time slot for your call, then go to the voice network. So this is the in between 4G and 3G. There's a LTE, and it's using CS fallback. But then after that, some country want to shut down their 2G or 3G. So most operator need to introduce a voice over LTE. So at this moment, all your network, your voice and your data is in 4G. So more or less the design will be like this. So you don't have MSC here. You don't see MSC, you don't see SGSN, because your signaling will come from your node to your E node B, going to MME, going to HSS. Then you have all your data here. Then when you want to make connection, this is your user plan, is the green one. It's connect from the E node B, going to SGW, going to PGW. What about if voice? MME doesn't need to paging the MSC, because the one who handle is this network, IMS. Actually, there will be detail in here. There's a task, there's ICSCF, PCSCF, so many. But this is this group of server, the one with that doing having the voice functionality like in 3G.
Okay, well, question, what's the difference between PGW and then SGW?
Actually, the functionality more or less, this is like SGSN, then this is like GGSN. So this one connects to the ISP. Yeah, actually the functionality more or less same lah from evolution to evolution,
like
but more
SGSN
optimized.
Handling. So more of them are handling packet switch. So there is no circuit switch anymore. So all of them are just fully packet switch.
Yeah, the voice also actually in packet switch in the core network here.
Okay. Okay, sure.
So then when Forte come, I think many operators already have Forte. They prepare the government if the government need to shut down 2G or 3G.
Okay.
Then we come to the new, we call 5G technology. More or less, this is what we want to share. What is 5G, expectations from 5G, 5G timing in 3GPP. I think if you are a telco guy, you know this 3GPP standard.
Yeah, so it's, 5G. For those who are not, 3GPP is similar to like a RFC in IETF in for those networking guys. So it contains documents that explain technology like the rules like protocols, right?
Yeah, it's the standard that we use.
Yeah, standard.
And then 5G architecture, 5G alternative option, and 5G core interworking.
Yes.
Okay, what is 5G? 5G actually the need of 5G, because they name it 4G already LTE, right? Long-term evolution. It will be long-term, but however, they still need this 5G because of several things. They need higher data rates. They have actually what is critical is about this part, the latency. Even you have the highest data rate, some of the equipment need a radio latency lower than 1 millisecond.
Oh, okay. So this picture explained the requirements for 5G.
Yes.
Oh,
so
okay.
more or less, the 5G will be the usage for this three group of usage. Extreme mobile broadband. Okay, extreme mobile broadband will be faster speed of the existing LTE we have, like this data rate. Then whenever needed, then more traffic it can handle. And also the massive machine communication. I think if you know some factory, they use very complicated machine with so many sensors. They will need more device with machine-to-machine connection with ultra low cost. Then 10 is on battery. Then there's a critical machine communication also with the latency. This is, for example, is a medical equipment. Nowadays, they have a rural medical, like people, the surgeon is here, the patient is somewhere in the other city. They can do the surgery remotely with the machine. But this is critical. Why? Because they need a real time. Even you have a high speed, but it's not real time, it will be dangerous, right? That's why the need of the 5G here, critical machine communication.
Yeah, so that's the impact of important requirement for 5G. The latency is less than 1 millisecond, so you can play game for that without any delay.
There is no delay.
Yeah. Okay, that's good.
Okay, the expectation from the community from the 5G is this one. Of course, the target will be 20 gigabit per second.
Wow.
We hope. Really? Then of course the lower cost per gigabyte.
Yeah.
Lower latency, as we pointed out. Lower IoT power, Internet of Things. If you have so many machines, actually the market of 5G will not be retail, I think. But we don't know in the future. But because in retail we enough with LTE, right? But more or less will be the sensor of the self-driving car machine, self-driving car, or maybe some robot. Then energy efficiency, and
so it's
then
more like machine-to-machine communications.
Yeah, I think their market is there. So actually, there's a huge opportunity for IT and telco guy in here in the future, because not only the operator, but also the UE or the MS, you say, the user equipment will be also need more optimal and more advanced lah. So many opportunity they say in the 5G for people like us.
Yeah.
This is the timing for 5G. More or less, this is the history from 3GPP. It's starting to study at 2016. Then it completed study. Then there's a non-standalone NSA completed end of 2017. Then they make a standalone definition. Then also this is the release they have. So each release in 3GPP will have additional what mandatory protocol they needed.
Okay.
Now they reach until release 18 in 2021. I think if you see some document in the release 18, they also put some satellite communication with the terrestrial.
Oh, okay.
They might.
So satellite is part of 5G for like a backup communication.
Yeah, actually, the cellular is the coverage of cellular is like 90% of the population, right?
Yeah.
But some part of the world cannot coverage by the cellular. In the middle of the sea, you cannot have cellular, right?
Yeah, sure. Yeah, but thing is, the requirement for 5G is 1 millisecond delay, right? And then if we use satellite, and then the satellite can be 1,000 milliseconds delay.
Yeah, satellites. Satellites. Disadvantage is about the delay, right? Because it's very far distance, you cannot have in here. But
the coverage is very, very wide.
Yeah, but some some people try to put satellite in the low Earth orbit, LEO.
Yeah.
They make the satellite is more down to Earth.
Close to the surface.
Close to the terrestrial. Yeah.
Okay.
Okay, right. This more or less the 5G, the 3GPP standard. You will find 25.xxx for the 3G and HSPA. For LTE, 36.xxx. For 5G, it will be 38.xxx.
Okay.
The protocol and the interface. Okay, but the architecture option. As we know, most of the communication provider already have their own network. Let's say 4G network, they already have, right? That's why you cannot push all people to go to 5G. Not all people will buy your 5G UE support, right? Even the Forte, they have a challenge also to move their subscriber to Forte, because not all people want to buy new phone like every 5 years or every 3 years to get a new feature. So not so many 5G support phone this day, I think. Even there is, it's still expensive. So the option that have for the operator is non-standalone here. If they have LTE and EPC already, they can put the radio, the core network first. This option 3, the core network still for LTE, they put the radio 5G as a trial. This is what the common actually in the operator in Malaysia. They put radio first. The core is still EPC. They still have HSS, MME, and all.
Okay.
So this is how they approach to change to 5G. Also, there's a possibility after they change the radio part, they change the core part, then they connect their LTE radio to the 5G core. This is also possible. After they move here, then they move the core part. This is option 4. Also, more or less, this one is the same. So you can have a standalone, and you can have standalone, and you can have interworking also between the LTE and 5G.
Okay.
Then okay, more or less, this is the node in 5G. Is much more than the current LTE and 3G. You have a 5G run. Actually, most of the changing in the 5G is in the core network, no longer in the radio part.
Okay.
So in the 3G, you have a map RANA protocol, but in 5G, the protocol, they will start with N. This N1, N2, N3. This is the node in 5G. And SSF, UDM. This is the replacement of HLR, HSS will go to this node called UDM.
Okay.
Then for the authentication, it will be done by the AUSF. MME function will be done with the AMF. So more or less, this is the whole network of the core 5G. It's a lot.
Oh, so a lot of changing on that. So F stands for function.
Yes, the F stands for function.
Yeah, in the implementation, looks like that function is represented by a virtual machine.
Yeah. Actually, that's what I plan to say, that this is so many nodes you see, but it's different with the 3G. Most of them is like proprietary box, and you install one server with one function. But here, they run in the virtual machine or in container. Some of them is also in container. So you can have like only blade and only small blade, like one enclosure. Then you have a
blade
several
server.
function. Blade server, yeah.
Yeah. Okay. Yeah. So one blade is one function.
Yes.
Right.
This is explain about the 5G and EPC interworking, like discussed earlier about the option here. Most operator, if they want to shift from EPC into 5G core, they can. There's an option for that. So there's interworking. So they have LTE, they have 5G run here. They still have MME. They can install AMF if they have money, and they also can add on because in LTE also some of them already in virtual box, so they can put here in changing the core network one by one, not changing all at once. So if you have 5G equipment like 5G phone, he can go to 5G run, or if some area he cannot have coverage 5G, he can go to the LTE. But somehow in the core network, they still have a service here. I think that's all, what I want to share.
Oh, okay.
Yeah,
it's done. Wow. Done. Okay, guys. So I think, yeah, that's all from our presentation today. I've done my part. Jemy also done his part. Any questions so far?
I don't know.
Maybe it's too advanced. Yeah, because it looks like when we talk about telecommunications, uh, um, the things inside the telecommunication is like a little bit exclusive, because it's the thing that you cannot that it's not available every day. So you have to go to the operators and then see the things. Yeah. Oh, I got a chat here. What is it? It's so fun hearing the history. Okay. Right. Thanks. Thanks for coming. Okay. And now why it's called operator trunk? Yes. Loop. Yeah. A call center. Yeah. Yeah. It's from history. Okay. Yeah. So we hope that after you attend this webinar, you need not you need you will get some enlightenment about how telecommunication works. You have an idea about how telecommunication affects other technologies like VLAN or networking. Why is it called switch, bridge? Okay, so it's because the function is similar to the central office, which is switching from one cable to the other cables. So same thing with the normal switch in networking. So it's switching from one cable from port 1 to the other cable at the port 2. Yeah, same thing, switches. And then we also discussed the evolution about mobile network from first generation to the fifth generation. And then currently, not all operators are doing the 5G, right? Jemy, yeah, in Malaysia. So some of the operator already done. That correct?
Yeah, they do this non-standalone already have. If you go to some area, you can get 5G network if your phone support 5G.
Yeah.
We already have trial with one of the operator here, like end of 2019 actually. So they already have some 5G run network.
Oh,
But
right.
I think, yeah, for your information, maybe 3G will be shut down in Malaysia end of this year.
Oh, okay. 3G. Okay, so all networks will be relied on 4G LTE.
Yeah, VoLTE or 2G.
Yeah.
They
I can
keep
see
2G.
also. Sorry?
They will keep 2G for the old people.
Yeah, because for 2G, I think one benefit of using 2G is because of their coverage. It can cover a higher coverage, but the speed is low. So I think it is enough for like EDC machines, like when you are in the market.
IoT lah.
Yeah, IoT. When you are EDC machine, if you are going to a shop and then you have to swipe your card, and then that EDC machine usually is put. There is a SIM card inside where they connect to the banking network. Okay. Yeah. So.
I think this question.
Oh, there's a question. I can see. Yeah, is there any next technology after 5G? Oh, I don't know. Or 6G or 7G maybe?
No, actually, they already discussed about 5G advanced.
Oh, 5GA. Okay, advanced.
Yeah, 5G advanced.
Okay.
Yeah, I
Yeah,
don't
we'll
know
see.
For 6G.
Yeah, because sometimes we learn from the history, right? Yeah, I was in Tanzania when I was when I was in telecommunication vendor, and then they are very happy to release their 3G network in Africa. But at the time, oh, you can make a video call. Wow, that's cool. Okay, but you can do the same thing with Skype. And now also with other technology as well, which is much more cheaper. So yeah, sometimes we expect to sell a technology, but sometimes in some cases it's not that successful. All right, so I think that's all. Thank you very much for everybody. I think it's time for photo session. So please turn on your camera, guys. Okay, and then please do thumbs up. Okay, so hope we see how handsome you are. Right, okay, so I will count 1, 2, 3. Okay, guys, please come on, turn on your cameras. Don't be shy. Okay, 1, 2, and 3. Okay, one more, 1, 2, and 3. Yes, that's cool. Okay, guys, so I think that's all. Thank you for coming for our webinar. The next webinar this week is on Thursday. Okay, and then the schedule is available on our website. Yeah, so oh yeah, I got info from admin. So regarding feedback. So please, oops. Yeah, so I'll just copy and paste over here. Okay, so hopefully you can see it. Yeah, so guys, so we have, so please submit your feedback. So the link is available there. Yeah, further event is available on the website. We have also Facebook. If you need more information about our schedule and then our program, slide will be available on Slideshare. Okay, here it is. Discord, we have Discord in Bahasa Indonesia. Recording will be available on YouTube. And then, yes, please stay tuned with our schedule. So again, thank you very much for coming. Keep safe and then have a nice day. See you in the next webinar. And good day, everyone. Thank you for the webinar. Goodbye.
Bye.